welcome everyone to our webinar. So the first thing I want to talk about is just really, what is modeling with MapleSim, just so we're all on the same page in terms of what we're creating as our, virtual prototype, kind of our digital twin. So when we're working with MapleSim, we're really doing system level modeling, and it's also going to be multi-domain. So connecting multi-body, hydraulics, electrical, we can combine all of those into a single model. And we're going to do all of this within MapleSim. Now, this is going to be equation-based modeling. So you're really just using your typical, physics equations that you would see in high school or undergrad. And of course, you can take it further and kind of develop your own equations, but everything is equation-based. Once you build your model, you can then go to Maple, kind of do further analysis using some of the built-in apps or creating your own. So this is if you really want to pull some information from your system and do some very detailed analysis. Of course, you can get preliminary or simplistic results from the model just by adding probes. And then finally, once you've analyzed your model and you've created it and everything is looking good, you can then export this to either an FMU or some C code. And of course, today the focus is going to be on the FMU export, which is going to tie into MapleSim Insight. So this portion over here. And we're also going to look at the modeling side. So in this webinar, we're really focusing on the modeling and simulation, and then moving to the MapleSim Insight, having an export as an FMU. So what is it that we're really trying to look at today, or what's really of interest? So thinking about, I have a PLC program, I have some control code that I'm creating or developing. Of course, this goes on to a PLC, some kind of little computer. And then the goal is to connect this with some kind of physical machine. So, my PLC program is going to be controlling my machine to perform some action, making sure it's doing it correctly. And then, of course, I want to be able to change things like how fast it runs, maybe the motion profile and whatnot. And of course, all of this is in the physical world. So this is a real setup. This is what you'll see in some, a factory line, for example. And in today's webinar, what we're really looking at is kind of the virtual counterpart of this. So again, we still have that same PLC program, that same control code. These are really identical. And then the difference now is we're going to be putting this on an emulated PLC. So that's where the CODESYS part comes in. And the connection now is no longer with a physical machine, but with a virtual prototype. Again, we're creating this plant model or this machine model using MapleSim. And then we're exporting an FMU with Insight to really, give kind of think of it as like a function block, kind of has some inputs, has some outputs. That's really what the FMU does. And then to connect the two together so that we can essentially test our code, we're going to use EtherNet IP as our communication protocol. So again, really the goal here is to emulate some physical setup in the virtual world. And the benefits of this is you can then try new ideas in your control code. So you no longer have this fear of, well, what if I try writing it a bit too fast? Would my physical machine break? Well, now I can actually do these tests in the virtual sense and really see, what are some of the forces, what are the moments, what am I going to experience in my system? And was the change I made to my code a good one? Was it a positive influence? Did it actually move away from the desired goal? And that's really the benefit of these virtual tools. So just to kind of recap, I know it's just summarizing. I just want to make sure we're all on the same page. So MapleSim Insight, these are coming from MapleSoft. This will give us the system level equation-based model of our machine. We then create an FMU that will be used with MapleSim Insight. And MapleSim Insight will give us 3D visualization, and we'll also be running the FMU. So in the sense of kind of computing terms, MapleSim Insight will become kind of our slave computer. Our master will then be CODESYS, which will be running our emulated PLC and running the code. And then we're going to communicate with EtherNet IP, which is just one of the few communication protocols for automation. And there is an interface provided in both CODESYS and Insight to facilitate this communication. And that's the other part that we want to highlight, is just showing that this connection can be made rather easily. So you're not spending a lot of time fussing over and trying to figure out how to actually create that connection. So with that being said, I didn't want to put too many slides together. I really want to just give a sense of what our objective is and really just move into the demo itself. So let me just escape here, open up. So we'll start from the modeling and the simulation portion. So what you see here is a MapleSim model that's been created for an injection molding machine. I'll run a simulation. So here I have a subsystem. I'm just going to go inside so that we can see the various components. And the results will pop up in just a second. So here we can see a connection between various domains. We have some multi-body, we have 1D domains. Here we have a cylinder, and these red lines are representing hydraulics. So this is where that multi-domain portion of the modeling comes in. All of these components are equation-based. So for example, if I right-click on a component and go to the help, I can actually see exactly what equations are inside of it, right? So here, some of it is a little bit just making sure every part is covered. So the position of the cylinder, how is the velocity calculated, kind of more simple stuff. But then the equations that will be familiar will be, force is equal to area times pressure. Of course, it's just it's a very simple version of a hydraulic cylinder, but this, in most cases, is a very good approach, very good way of kind of including those dynamics into your system. So I've ran a simulation, and I can actually pull up the results. So I have built this using our CAD import. And so an injection molding machine, maybe I'll just make this a little bit bigger so everyone can see very clearly. So this is our moving platen. So these gray pieces are essentially a mold. They're going to be kind of some big steel. They're going to be pushed together, and some plastic will flow here, will be heated up, and is going to be pressed together to create this mold. And then some air will usually push it out and make the mold fall down and then get collected. So this is really, this is our plant model. This is the thing that we want to control. Now, right now it is moving back and forth. I've added some kind of control in MapleSim, but it is very simplistic. So of course I want to develop something more, maybe more sophisticated using an actual PLC programming tool like CODESYS. But this is just to give a sense of what you can do within MapleSim. Again, I can pull up those plots that were being displayed. So all of these results are coming from probes in my system. So if I just jump back to my model quickly here, and I'll go up one level. So I'm at the top level. So for my subsystem here, I've created one input, which is the command for my DCV valve, which we'll jump into. And I have multiple outputs. So I'm looking at the desired set point, which I've put inside my actual position. So of course, my actual position and my set position are the two things going into my controller here. And then I have some other outputs. I have pressure, I have power. Really, you can probe anything in a digital model, which is always one of those nice things. It's not always realistic to probe anything and everything in a physical system. Right, so just going inside of our model, here I have my input, which is going to my DCV, and that's going to be controlling which path my hydraulic fluid is taking to either extend or retract the cylinder. And so that's really forming the basis of this model. And of course, because I have those probes and all those outputs, I can go to my results and I can see the various results for the pressure, what is the command that's being given to the DCV, RPM, speed, various quantities related to the motion. And then maybe more interesting, I can see how my actual position is doing compared to my set position, right? And of course, this is going to be dependent on my controller parameters. So let's just say that I've been working with this model. I'm happy with it in the sense that I'm confident it captures the main dynamics of what I'm trying to model, which in this case is the opening and closing. And now I want to actually export this as an FMU. So what we do is we navigate to the left-hand side of MapleSim. We go to one of our FMI connector add-on. I'm just going to double click on this FMU Generation. It's going to open up an app for me, which is just essentially just an app is going to help me just work through the steps and generate the FMU that I need. So in this case, I select the system that I want to export. I can take my whole model. I can take parts of my model. In this case, I'm just going to take the actual plant portion. So that part that has the hydraulics and all those inputs and outputs we were looking at before. Now hit load. What this is doing is it's actually connecting to my model, loading in all the information, and that's just going to help me ensure that my inputs and outputs and all those things are kind of in order and what I'm expecting. So for the inputs, I have the command that's going to go to my DCB. For the outputs, I have those same outputs that I saw earlier. So my pressures, my power, and then my actual and desired positions. For parameters, I have quite a few that pop up. What I'm going to do is I'm going to hit clear all. I only want to choose a few of them that I want to actually be able to change or modify while I'm running my simulation. Most of these I actually just want to keep constant. So the two that I want to change are these. It's this add M and K RPM. These have to do with just, so the add M is an extra mass that you can add. So this could represent different weights for different molds. The K RPM, this is just a gain factor. So I'm going to set those to tunable. I can double check this here. And again, this just means that once I generate my FMU, I will have access to these in the same way that I have access to inputs and outputs. Every other parameter in my model will be fixed to whatever value it is currently. So now the last step is I have to pick my export options. So, for the most part, these are going to stay pretty much the same. For the solver, I've played around with the solver in MapleSim, right? So if I actually go to my model, I can go to my simulation settings, and I found that an implicit Euler works well with a 0.1 millisecond time step. Again, this comes kind of from trial and error. Why use an implicit Euler? It's a little bit more stable, and it works well for hydraulic systems, and still has a good speed. So my communication step size is set to 1 millisecond, but to make sure that I replicate the solver settings in MapleSim, what I'm going to do is I'm going to actually check on this advanced settings, and I'm going to add some internal steps just so that my step size here is matching the step size that I found worked well in MapleSim. I won't touch any of the other advanced options. They're really more for specific cases, kind of more difficult models that are kind of more challenging to run in a sense from the solver's point of view. I'm just going to change this. I'll pick my desktop as my location to save. And I'll just call it plant. So I hit generate FMU. And so what it's doing is it's creating this FMU and it's adding this insight data, which is checked on by default. And this provides the interface or essentially the necessary details so that I can then load this FMU in MapleSim Insight. So what it's doing is it's actually creating this FMU. And again, this FMU is not proprietary to MapleSim. This is kind of a standard, an open standard that many software companies are following as means for passing along models or pieces of code to various systems. So it provides a nice way of being able to take your model from MapleSim and bring it to other programs. So we see here it's generated. It's giving me a view of the C code that was actually embedded. But if you're not interested and you just care about the FMU, you can just close it, move on. And this is really everything that encompasses the MapleSim portion. So now what we need to do, and I'll just minimize my, I do have a virtual machine that I had to set up to make this communication possible. So I'm going to open up MapleSim Insight. I'm just opening it up on my other screen right now. So I've opened up MapleSim Insight, and first thing I need to do is to actually load the FMU that was just generated, right? So my plant.fmu, and you'll see the visualization appear. Down here we have kind of empty plots right now, but it's all the outputs that we had from our FMU. So again, because I had that CAD imported into MapleSim, it gave me the 3D visualization of my results in MapleSim. It also gives me a 3D visualization inside of Insight, and that just helps with visual debugging. It's also nice to see the results kind of in action. And what I need to do is create an EDS file, which gives details on how to communicate with the FMU when I want to connect through Ethernet IP. So I go to the Ethernet IP tab here, and I'm going to click on Create EDS. Again, it's just showing me a summary of kind of what's going to be included inside of it. I'll just hit Save, and I'll just call this plant. So we've saved this just again to the desktop. I'll load it up, use these details. And then there are some details related to the IP. So for this to work, I did have to change my my IP address, and I forced my laptop, which is going to be running MapleSim Insight, to use this IP address. And then I do have to set it up on the virtual machine, make sure they communicate. Not too difficult once you just go into the settings and kind of go from there. So, but this is all that we need to do in Insight. Really now it's going to sit idle until we have everything connected on the CODESYS side. And then we'll see this running in action once we start running our PLC and start communicating. So for now, all we've done with Insight is loaded up the FMU and created our EDS file. Now I'm gonna move to a virtual machine, and this is where I'm actually hosting CODESYS. So I'm just gonna minimize this for now, and I'm gonna copy over that EDS file that we just created. So going to my desktop, grab my plant EDS, paste it here. I already have my file open, my project for CODESYS open. Really, only part that exists right now is really the program itself, just to not have to code everything on the fly. But really, I'm going to go through the steps of what it looks like to kind of bring everything in. So the first thing I want to do is I want to take that EDS file I just created, and I actually want to create a device from it. And this is a device I'll be able to add in CODESYS, and will basically enable the communication. So I'm going to go install. I'll pick the EDS that I just copied over. And we can see that it actually creates a device called MapleSim EtherNet IP adapter. This is what I'm going to need later on. So I'll close this for now. I'm going to go to device, and I'm going to start adding devices, essentially setting everything up for that Ethernet IP communication. So the first one I need is an Ethernet adapter. So I add this device, and you can see it's being added to the tree. And then I pick the Ethernet I want to add to this. So I need a scanner. And then finally, onto that scanner, I'll be able to add the MapleSim Ethernet adapter. Here, so I'll add that final one. So these are all the devices that I need to be able to set up the communication. Now I just need to do a couple configurations. So first, I want to make sure that my PLC is running. So I'm going to start my PLC, and I will make sure that I'm connected. So I'm just going to go to device here, kind of the top level one, right? So make sure that I can make this connection. Perfect, everything is green. So now I mentioned that the Ethernet IP, the IP address on MapleSim Insight, again, I had to set up the IP address on my virtual machine. And we'll see when I go to my network here, I'm going to pick this one here. So 192.168.2.10. That's going to be my master IP address. So I'll hit OK. And this is the only setting I need for this first one. There's nothing that I need to change in the second one. And then I move to the final one. So this IP address is going to match my MapleSim Insight. So this is 211. We'll just double check that. So, yeah, 211. Connection, it's the RPI. So the kind of the rate of packet information is going to be 10. So I'll set that to 10 here just to make sure that they're in sync. And now the last thing I need to do is I need to essentially connect this adapter to my PLC code. So if I go to my PLC code, maybe we'll start with the diagram. Diagrams are always a little bit easier. So I've pulled in this controller block. The output is really my kind of the control signal. So this is the signal that's going to be sent to my DCV valve. This controller takes in the actual and set position. So these are two values that are actually exported from my FMU. And then I also set some controller parameters, so a gain and a time constant. And then this part down here is what I'm using to actually synchronize everything. So I have a simulation time that just keeps kind of stepping forward. And I pass this simulation time to my FMU, and that's going to allow my CODESYS PLC and this to run in sync. And that has to do with these options here on the left. I'll come back to those. But essentially what all you really need to think about here is that you create some tags or some variables that you know you're going to be able to connect to the actual FMU. And again, these outputs from the FMUs and the inputs are coming from, going back to my model in MapleSim, when I selected this subsystem as being exported to my FMU, it had this as my input and these here as my outputs. So I know that those are available to me. So I'm going to go back to my CODESYS program, right? And then of course up here, we just have the kind of type definitions and initializations for the variables. And now I'm going to go back to my MapleSim adapter, and I'm going to tell it how everything is connected. So I go to my IO mapping, I expand this here, and I can see these are all the available inputs and outputs and also the parameters, right? This add m and the KRPM that we defined when we were exporting. So these are all available to me, and I just need to map them to my program. So my plant position, this is my actual position. So I open up the options here, go to my program itself. I can see, what's available to me. So it's my actual position. Set point is my set position. My FMU input time, again, this is that sim time, which is just a variable that's going to help synchronize everything. My command is my valve signal. The add m parameter is add mass, and then the KRPM is KRPM. So I have everything connected. At this point in time, I don't have anything inside of my code that really needs the the pressures or the powers. However, they would be available to me if I wanted to either just kind of watch those values, or if I wanted to incorporate them into some kind of more elaborate control scheme, or if I was more interested in the hydraulic portion. They are there, but I'm just not going to use them. For this one option, I'm going to change it to enabled 1, which is just going to give me all the values as it's running. Otherwise, it would only show me things that are connected. So kind of a minor detail. So now I'm going to log in. Essentially, I'm putting everything onto my emulated PLC. So just asking if I just want to run it. So I hit yes, kind of putting all the code. We'll see it's going to initialize. All of these things will kind of show the current value. Right, so everything is kind of set up, waiting to go. It's telling me the bus is not running. That has to do with MapleSim Insight, because again, that nothing's happening there. So I will try to just minimize things as best as I can. Try to put it, half and half, so that we can see both of them running at the same time. All right. So this is kind of turned on. It's ready to go. Let me just fix this view a little bit here. There you go. Just need to minimize this a little bit. There we go. All right, and then what I'm going to do is I'm going to use those options on the left to actually tell my system that I want it to be synchronized, so that it looks for that time input and kind of make sure it doesn't go too fast. So I'm going to select the wait for simulation start and sync with simulation. I hit play and we see the system readies itself. So here we can see nothing's happening. And now all we have to do is really just hit play on CODESYS. So we hit play and everything should just start running. So again, it's just using default values, but we can see it is moving as it did in MapleSim. It might not be exactly the same because of course our controller slate is a little bit different. But now what I can do is I can start playing around with different values and see what happens. So I can go to my PLC program and I can look at these variables. I'll just move some things here and I can actually pass different values. So for the added mass, I can increase it to 1,000, right? Pass this along. And I'll try not to go too crazy with my steps. Of course, if I just all of a sudden give it too much mass, it might cause some errors in the integration, kind of cause my model to run into some problems. But we'll try to increase this a little bit more, maybe 5,000, right? And we'll be able to look at the results, but you can already see that some of the pressures are increasing as I increase the mass here. I'll bring this back down to 0. And maybe I'll play around with my KP value, so the value that's going into my actual controller. Again, I won't change it too much essentially for the same reasons as before. Try to wait till it's maybe a bit more still. So I'll pass this value, right? And again, if I'm looking at the values, you can see what's happening live with MapleSim Insight. Yeah, so now because of my controller value, it's really trying to push a bit too hard. So I do run into this failure. Again, this is one of those things where because I've changed one of the parameters in maybe a way that was too big, it is just kind of causing it to run into an issue. But then we can actually see what went wrong. So I can actually go back to my model. So I still have all the results available for me. Maybe the first thing I'll look at is I'll look at my set position versus my desired position, and I can see how changes to the mass, changes to the controller were really affecting things. And maybe we can get some insight into, maybe what happened or what caused my system to actually not perform anymore. So I'm going to go to my outputs. So the first one is I'm going to do my set position. I'll create a new plot window. I'll go to my actual position and add it to it. Make this big. Right, and so we can actually see when our system started off, we're in this range over here. And we can see that our actual position is not quite hitting that 0. So, I mean, the system is trying to get it there, but of course, because of the parameters, it's coming a little bit short, but it is doing a good job the other direction. And then, of course, we can zoom out, double click. Oh. I just need to make this. Just show it again. There we go. And then, of course, once we change the parameter, so we see we increased the mass a little bit, didn't change too much, but then as we get here, we see that the mass is actually moving a bit beyond the set value or the desired value. I'm getting a little bit closer here. And this was when we had the 5,000 kilos added on. So see how the system is behaving. And then we turned it back to 0. We can see the results. And then, of course, when we turned on the extra controller, it seems like it might just be, it could have something to do with when it's coming to close. Likely there's a pressure that's maybe shooting a little bit too high, causing kind of the FMU to go beyond some of those error tolerances. But these are all things that we can then play around with, check into. But of course, I can always just restart my system and kind of look at the results again. So I'm just going to close up MapleSim Insight. I'll reopen it just to make sure that there's no lingering kind of failures or anything like that. I'll disconnect everything for now. I'll reconnect here. Actually, I need to stop this. Right? I do need to tell it to stop. So I will load up. I'm just loading up my plant FMU on an Insight again. Just loading that EDS file. So back to where I was previously. So I can hit, okay, this is all ready to go. I will make sure that my sim time is listed at 0, since I do want it to just start at 0. Hit the play button again, and I'll hit play again. And we see that our model is running once again. Right, so as we're going through and kind of, running our simulation, if we wanted to stop and check something midway, we can always just essentially pause the simulation here. We see that Insight is also stopped. CODESYS is kind of paused. You can investigate the results, see what's going on. You can go back and kind of just see if there's anything that gives you some indication of something incorrect is going on. Maybe change some of these prepared values, and then I can just resume my simulation kind of from wherever I paused it. And so this is really the connection. This is really what I wanted to kind of show today in this webinar. Maybe one last thing, if I do disconnect this and stop, if I stop this, I do have all of my results available, just as it did when we ran into the previous error. If I just stop it normally, I will have all the results available, so I can review the animation, review the results. And if you do have this visualization, one of the other options is you can actually record a video of the results. So maybe you want to include it in a presentation, share the results with a colleague, manager. You can actually record this and export the results and really have everything to kind of show what your analysis showed. Especially if you're trying out new ideas, you want to be able to back things up with numbers and with visualizations. But essentially, this is what I really wanted to show today. Maybe just a quick recap of what we looked at. We started with a model in MapleSim, so a system level equation-based multi-domain model with multi-body hydraulics, some pistons actuating. We created an FMU from this, which we had Insight data, which then allowed us to load up the FMU inside of MapleSim Insight. This is where we can see all of our results. In Insight, we created our EDS file, which kind of dictates or gives information about the communication when we're using Ethernet IP. From this EDS file, I then went to CODESYS. I was able to create my PLC program, load the EDS file, and then kind of connect all the inputs and outputs of my FMU to my actual control code, and then run this emulated PLC, synchronize it with MapleSim Insight, and be able to play around with values, see how changes to my program can influence my system, and then can review the results in MapleSim Insight